We're now going to hear from Shui Zhang Fei, Department of Horticulture here at ISU, on turf grasses. Thanks very much.
Thank you. Oh, sure. Okay, great. Thank you. Good morning, everyone. Welcome to Iowa State University. Again, my name is Shui Zhang Fei, also known as Fei to some of you in the audience here. So my specialty is on turfgrass breeding and genetics, but what I will be talking about today is going to be utilizing turfgrass as a perennial ground cover for maize production. So I'm not very good at keeping times. I'll stay on time, so what I'm going to do is to do the most important things first, so which is to acknowledge the people who work, who generate the data and analyze it. And this is mostly the work I'm going to talk about today is going to be the work of a former PhD student, Ellen Chen, and also current students, Patrick Gallen, and also my colleague Ken Moore and Annie Lanson and Roger Hens. And the work was primarily supported by USDA NIFA as well as Iowa Nutrient Research Center, and with seed sources from private companies. Okay. So now, for using turf grasses as a perennial ground cover is a relatively new concept, and so I'm going to spend a little time talking about why we are doing this. We're not crazy. Hopefully you don't think so. I guess everybody here in the audience is familiar with some of the problems associated with the current agricultural system. We know it's very highly productive, but at a greater cost, environmental cost in the form of soil erosion and the nutrient leaching, as well as decline of organic matters, right? So, but everybody in the audience is also aware that we are, using a cover crop is really being emphasized these days, even though the adoption rate is still low. But annual cover crop can address some of these issues that I just mentioned. But for regions like Iowa State or most of the states in the Corn Belt, we have a relatively short growing season. So when you are adopting the annual cover crops, it will narrow down the windows for planting of the crop following the cover crop, as well as harvesting of the prior crop, right? And also, this will add additional cost for replanting, okay? So that's how we came to the idea of using perennial grasses as a perennial ground cover or cover crops. So basically, when you think about the Midwest landscape, when you think about 100 years ago, is pretty much dominated by perennial grasses and the forbs as well, right? So, as a group, perennial grasses can certainly reduce soil erosion because they have a large fibrous root system that can cling to the soil very strongly, and also improve water infiltration and to slow down surface water runoff, as well as reduce the nitrogen loss to waterways, and also certainly building the organic matter, which is what gives us the most fertile land in the world, right, in the first place, okay? And when you look at the grasses distribution in general, there are basically the cool season grasses that is distributed in the upper half of the United States, as well as some of the warm season grasses in the south, and then the transition zones. So the cool season grasses primarily consisted of a group of 20-some species that is used extensively for forage and turf. And this is the one I'm going to talk about, okay? So first of all, why we think a cool season grass might work, whether they have what we're looking for. C3, those cool season grasses all have C3 photosynthesis systems, and they prefer cool and moist weathers. So they thrive well in this early springtime, also in the fall time. Starting now, they are coming back, but in the summer times, they suffer, okay? But on the other hand, when you think about the corn and the soybeans, they prefer hot weathers. They love high temperatures. And also, they have additional features that we're looking for. Most of these grasses have a shallow root system. I just want to highlight, for example, this is a very highly cited figure. I'm just citing a part of the figure here. As you can see, this is a Kentucky bluegrass. If you look at the grassroot system here, it's barely go beyond 1 foot. Okay, so but when you think about other grasses or other maize, easily go beyond 6-7 feet, right? So this is how my colleague Ken Moore in the agronomy department, many of you probably know him, his group started to look into using cool season grasses as a perennial ground cover about in the 2006 or 7 or so. And they showed that with chemical suppression of the cool season grasses, they can actually achieve comparable maize yield when they are co-planted with cool season grasses. That is how I joined the bandwagon, I guess. So the objective for the work I'm going to talk about is basically to determine the compatibility of USDA green accessions of Kentucky bluegrass, red fescues, and Sandburger bluegrass with maize production without a chemical suppression. Now, because my focus is primarily on the breeding and the genetics, so hopefully we don't have to use the chemical suppression, which certainly, as you think about this, it's going to add additional cost and perhaps also environmental concerns. So the hypothesis is because even though the history of breeding turf and forage is relatively short, but we are, in the process, we are selecting against some of the traits that would be considered as desirable for perennial ground cover, which, for example, summer dormancy is one of the things we try to select against because we want to develop turf or forage as more persistent, right? So, the little bit about the experiment method we used. We used 20 accessions of each of these 3 species, and we started with spaced plant. And you may ask the question, why don't you use broadcast? So the reason being that USDA green accessions are oftentimes only providing us about 200 to 250 seeds each. So we don't really can do broadcasting. And we use the experiment, the plot size is relatively small as well. It's about 0.76 times 4 meters. And the maize was planted and evaluated in 2017 and 2018. I'm not going to burden you with all the details, but just to highlight some of the more important measurements that we took. One is the grass coverage. And as you can see, on the x-axis here, this is the day of the year, and the vertical axis here is the percent of ground cover. And as you can see, in the early part of the year, the ground cover is fairly high, and during the summertime, it started to decline. And so this is the first year, and when you get to the second year, the trend is similar in the early springtime is high and then go down. But one accession as a group stands out is the Poa sequenda, which is a summer dormant species. So year-round, the ground coverage is relatively low, okay? But Kentucky bluegrass as well as the red fescue, both of them maintain acceptable coverage, okay? And then comes to the most important things that we're looking for, the grain yield. So if we look at 2017, all these 3 species maintained the yield is pretty comparable to the ground cover control. But then when you move to 2018, then the yield, that year we also had a very lot of precipitation. And even the controlled yield is much lower than the previous year. But the plots planted with Sandburger bluegrass actually had a pretty comparable yield to the non-grass control, even though the Kentucky bluegrass, particularly the red fescue, because it's non-summer dormant. So it maintained a pretty aggressive growth. The yield really suffered, but still we consider as decent. So just to explain what we have observed, the three species we used again is the red fescue and Poa secunda and the Kentucky bluegrass. Both the Poa secunda and the Kentucky bluegrass have summer dormancy, even though Kentucky bluegrass is only what we consider as equal dormancy. In other words, it will go dormant only in response to lack of soil moisture. But Poa secunda, however, it does respond to high temperature as well as increase the photo period. So it's more reliable and more consistent in terms of summer dormancy, okay? And this is just the next couple of slides just to show you. Remember that for each accession, we have, for each species, we have 20 accessions. So the previous slides on grain yield, we showed for each species as a group. Now we look at the table in which we showed for each accession how they respond in terms of grain yield to the perennial ground cover. So, for example, if you look at the first column here, Kentucky bluegrass, and the maize grain yield here, this is for 2017, and also Sandburger bluegrass and red fescue. So what I want to highlight here is basically for each species, there are clearly variations among different accessions, okay? This is basically the take-home message. I don't want to really spend a lot of time to go through the details, but this is what, and also it's similar in 2018, and we did find a few accessions that that are consistent between the 2 years, okay? So, so the general conclusion from this experiment is that maize with summer dormant Sandburger bluegrass had a comparable yield across 2 years to that of the control, okay? And also variation exists among accessions within each species, and this is what we really are interested in because that's the basis for future breeding, and which, you know, obviously looks like that there are quite a lot of variation we can take advantage of. And also to emphasize the point I just made is some of the Kentucky bluegrass, for example, these accessions here, and also for a couple of red fescue accessions, they're pretty consistent across 2 years that are high performing than the rest of the group, okay? So now, what's exciting I want to report in here is that we now are advancing to a larger scale evaluation of some of the commercial varieties of Kentucky bluegrass as well as a bulbous bluegrass called, the scientific name is Poa bulbosa, which is known to exhibit a consistent summer dormancy. And we also increased the plot size, and so in this case, what I'm going to report is primarily focused on these two species, and the plot size we increased to 6.1 to 6.9 meters. Basically, it's 8 corn rows, okay? And we take samples from the center 4 middle rows. So what we did is we established the grasses in the fall of 2019, broadcast. It's much like a turf establishment. And then in the following spring, we use the strip till to create a grass-free tillage zone where the corn is going to be planted here. And this is what it looks like in this time of the year, the following year here. These are Kentucky bluegrass. So what's really excites us is the yield data. So in this case, we have a control, and we have a Poa bulbosa, And we have 4 different cultivars of Kentucky grass, and one of them is a mixture of 2 varieties. So as you can see, in 2020, the Paul Barbosa, we had a slight yield reduction. But in 2021, actually the yield for Paul Barbosa plot actually over-yielded that of the control, which is kind of interesting. We asked the question why this is the case, and we worked with our colleagues back in Oregon who supplied us the seed. And what they were suspecting is whether, because they are summer dormant, they produce little bulbs, they form a layer of ground cover, which may preserve the soil moisture that give these plots a little bit of advantage here. But it's still too early to say, and this is the 3rd year we're looking forward to the yield data this year. Okay, just to give you an idea how Paul Barbosa behaved in the field, and this is what they look like in June. They start to, typically they will go dormant in late May, and will completely go dormant in the summer, in the middle of June, and throughout the summer until September, early September, when a precipitation will deliver its regrowth in here, as you can see here. Now, this grass has been typically used as overseeding in the South, in golf courses and the sports facilities. But right now we are evaluating its potential as a perennial ground cover, which obviously shows a great promise here. And this is, again, just want to thank the 2 grad students who did the work. And as you can see, on the left side they are standing on a plot was the maize co-planted with Kentucky bluegrass, and on the right, it's maize co-planted with Paul Barbosa. And as you can see, the plant height on the right side is above their heads, and on the left side is at their shoulder. So with that, I think if I have any questions, if I have any times, I would certainly happy to answer questions. One question? Okay.
We have time for one question.
By the way, I am from Iowa State, so if you are interested in catching up with me after the meeting or want to see the field, feel free to contact me. Okay?
Hi, thanks for your talk. It's exciting to see you looking at so much variation within species for covers, since ecological traits do vary. So, but I'm just curious, in terms of weed control that these different perennial grasses might convey, it looks like the ones that go dormant in the summer, there might be a lot of breakthrough weeds that wouldn't be doing much weed control, but I wonder if you saw differences among the species in their ability to control weeds.
Yeah, that's a good question. One of the purposes using those perennial ground cover is also to suppress weed. And for some of the Kentucky bluegrass accessions we have, they exhibited quite a good weed suppressions. Actually, we don't see a lot of, obviously, we are still, because we grow Roundup Ready corns, right? They are still using this herbicide, a weed control common practice to do that. But even for Paul Barbosa, when they go dormant completely in the summer times, we don't see serious weed invasion at this point. So we didn't see a lot of problems. But that's, yeah. Okay.
Okay, thank you very much. Sorry.
Yeah, thank you.